Welcome to the TDRS CSP Townhall. I'm Caitlin O'Neill, Director of Strategic Communications, and I think I speak for all of SCAN when I say we're so glad you could join us today for this important conversation on network sustainability. Today's town hall will focus on NASA's transition to commercial relay services, where our panelists will discuss the benefits of a commercial-first approach. With us, we have Mr. Greg Heckler, SCAN's Deputy Program Manager for Capability Development, Mr. Joseph Downey, Project Lead Engineer supporting SCAN's Communication Services Project, Mr. Stephen Creech, Assistant Deputy Associate Administrator for the Moon to Mars Program Office, and Mr. Andrew Maynard, SMD Assistant Deputy Associate Administrator for Programs. Reliable space communication and navigation systems are critical to every NASA mission. Spacecraft commands never-before-seen images and scientific data are sent and received daily through NASA's network. For over 40 years, the Tracking and Data Relay Satellite Constellation has provided resilient communications and near continuous information relay services to a wide range of space missions. This includes the Hubble Space Telescope, the International Space Station, and countless human spaceflight missions. Stepping into the next phase of space communication services, industry will work alongside NASA as new missions leverage their network capabilities. Commercial space partners will expand our space infrastructure, driving forward space communication capability, development, and operations, ultimately providing greater opportunities for discovery. Whether you're here today to get answers to your questions or simply listen and learn, we hope you will walk away with a better understanding of NASA's path forward. Now, it's my pleasure to introduce Mr. Kevin Coggins, who will be moderating our panel discussion. Kevin is the Deputy Associate Administrator for the SCAN program here at NASA and is responsible for the development, acquisition, and management of reliable and cost-effective communications and navigation services to support NASA and other government agency space requirements. Today, he's working with commercial partners to build a sustainable space ecosystem, one that will accelerate innovation and offer a vibrant market while also ensuring user needs are met. Kevin and our panelists will answer questions and share more on how NASA SCAN is transforming space communication networks from a government-centric paradigm to a commercial, collaborative, and interoperable network. Kevin?
All right, thank you, Caitlin, and thank you to everyone that has joined us here in the room, virtually, and thanks to our panelists. I'm looking forward to a very exciting discussion today, a continuation of discussions some of us have been having, and the beginning of a discussion, that's going to include RFIs, draft RFPs, and ultimately a new capability. Many of you are familiar with the TDRS constellation. It's been around for decades. Many of you might not know it was one of the things that the space shuttle carried up in the shuttle missions. They usually had a TDRS satellite in the bay. And once, before the TDRS satellites were up, the astronauts and people in the ISS, they got time off, right? There was time when you couldn't talk to them, and they enjoyed that. I've talked to many astronauts still in NASA, and they really enjoyed that time when they could just have, time on their own and to themselves, not being told what to do every minute. But then we got a lot of TDRSs up there, so we had continuous coverage. We've launched science missions that have used TDRS. We depend on it for human space flight. We depend on it for launch. It is an amazing capability. However, it is an old capability. It's an aging capability. It's a government-owned, government-operated capability in Earth's orbit. That doesn't make business sense anymore for the government, and it also takes away market share for industry. And so one of the purposes of our CSP program is to help grow this commercial space ecosystem around the Earth so that we can move missions off of TDRS and from these launch needs and from human spaceflight to commercial partners. But market forces determined what people built under CSP. So we had a couple things that were left out of that, mainly some of the unique things TDRS provides in S-band and Ka/Ku band. And so we have missions that still need the capability, but TDRS is at the end of its life. We seem to be retiring a TDRS satellite every year. And come 2030, we're only going to have a couple left. And in the 2030s, right, we'll see the constellation switch off, go away, get completely retired. So by then, we need to have something that can provide some of these capabilities. We still want market forces to drive what we do, but What ties us is S-band, Ka-band, Ku-band. So what we want to do is work with industry to figure out how do we make these bands available to you in a commercial platform so that you can service us and then bring others that like to use those bands or could into those frequency bands. That's a big move. That's a big move. You know, NASA's, in the early days of NASA, when let's even pick on Apollo, right? We had to build infrastructure all over the world. Government-owned, government-operated infrastructure everywhere. Direct-to-earth antennas. We built little towns all over the place around these capabilities. Over time, some of them shut down. Some of them that grew into what's the deep space network today, and even some near space network elements. But there's one special case I want to talk about, which is kind of a model for what we like to do at NASA in SCAN with commercial partners. And it's the KSAT model around the Landsat mission. We built this antenna at Svalbard, and after the Landsat mission, we kind of didn't need the antenna anymore. So we turned to our partners over there and we said, do you want it? And KSAT in Norway said, you know, we're going to scale a business around it. And now they're one of the largest DTE providers in the world. We see what we're doing with TDRS here in CSP with this follow-on activity as a similar thing. We have the spectrum and we have users. Do you want it? Let's work that out. Let's figure that out. We're trying to take a very commercial first approach. We understand, in this case though, we have to drive some requirements in it because we need backwards compatibility for our science missions. We need backwards compatibility for certain things. But we're not going to restrict you to just our requirements and our needs and the ways we use the frequency today. So I think that's very important to note. I'm excited for this panel today. We've got all of your questions. I've got a big stack of questions here. And in just a second, I'm going to begin the moderated discussion. I got a final note. Industry partners, one reason we're being so forthcoming with this information and broadcasting so much, and that we're going to share so much in the RFI, is because we can't do it alone. We know you can't do it alone. We want to encourage you to work with each other, form partnerships, form a competitive field to come after this competition. We want you to have close dialogue with us constantly. Come visit us, come see us, talk to some of these leaders on the stage, submit questions, submit white papers, shape this. Before I was at NASA, I was in industry. If you don't shape it, you don't win it. So what I'm encouraging you is shape this, learn, ask questions. And this is one of many forums you're going to be able to do that. So thank you for coming today, and let's get into some of these questions. And welcome, panelists. Thanks for taking the time out of your day.
Welcome, Kevin.
All right. The TDRS constellation is declining faster than anticipated and will no longer support new missions, only existing missions. What is TDRS flyout timeline, and can you share how we mitigate anticipated risks? Greg Heckler.
Sure. Thanks, Kevin. And let's advance the slides in the next one. I had the privilege and opportunity to be asked by the agency to help lead us through this transition for about 4 years now. I also had the privilege, before I came to NASA headquarters, on working the so-called third generation TDRS project for about 6 years. Those are some of the dearest experiences I've had, and understand the people in the mission make it really, really important, right? It's just not about the things we build, it's about who we do it with. TDRS, a long legacy, started in the 70s, of course, right? Coupled with shuttle. Those in the common nav business understands there's a connection actually to GPS as well. There's a common community, common technology there. But that legacy is here with us today. Every astronaut conversation from the space station, every picture you see from the Hubble Space Telescope has come through this constellation, this capability. As I've learned a lot about the agency going through this transition. We've had thoughts about what this forum really is. It's about the future, but it's also about recognizing not just the capabilities, but the people who helped build it, multiple generations. Yeah, I worked on third generation TDRS. I was really the third generation, third cohort, that first being the people in the 70s who had the dream, the vision, worked to get those initial satellites up, right? Build out the first ground station at White Sands. Worked on the first generation of TDRS, TDRS 1 through 7. Then there was a second cohort. Some of you may know them, Jeff Gramling, Dave Littman, who's no longer with us, Paul Buchanan. I had the opportunity and privilege to learn from them during my experience on that project. And so today you can think of it, this is a retirement party. And so I'm going to talk a little bit about the TDRS mission, what it's helped us do, and how we're going to approach that retirement. So before I get into that, if this is a retirement speech, let's give a round of applause, not to the capability, but the people that have dedicated their lives and careers to this system over the last now almost 50 years. So let's do that. Thank you. Next slide, please. So Kevin talked a little bit about the missions that TDRS enabled, talked about it being coupled to the shuttle, right? Conceived at the same time in the 70s. Yeah, the TDRS launched, TDRS were launched on the shuttle missions, TDRS 1 through 7. Some of you may not know, the payload in the Challenger was actually a TDRS satellite that we lost. So we understand the importance of human space flight and safety. So it enabled the shuttle. Of course, the ISS, I don't think could have been built without TDRS, the high data rates, the continuous connectivity, allowing us to see those helmet cams in real time. We had one of our leadership from the ISS come over yesterday. We had a blip in our Guam ground station, and we lost coverage over that area of space. And the first thing they did was march down to the scan office. When can you recover this capability? We have a spacewalk going on. It's safety of life. We need to see the helmet cams. So we understand that. We have our human spaceflight representative, Steve Creech here. We want our user community to understand we know those things, and we want our new industry partners to also appreciate what we're asking them to do. Of course, ISS evolved, right? As the shuttle was retired, there was COTS and commercial crew. The agency made a decision, right? We always talk about risk. We wanted those industry partners to focus on certain risks, and that's building the spacecraft, not how you communicate it with it. And so we made a choice at the time, hey, we're going to offer TDRS. That's your catcher's mitt. That's your safety of life. I had one colleague called SCAN provides the air to the rest of the agency. And so we wanted to make sure our industry partners didn't have to worry about that at that time. And so TDRS was built into several of the COTS and commercial crew vehicles. Artemis itself, right? Orion, SLS, maybe even some initial support to help bootstrap some of the human landing systems, their needs in LEO. So it's making contributions there. Launch vehicles, great dialogue over the last 6 months with the commercial and international launch vehicle community. In the late 90s, early 2000s, again, we made a national decision with this national asset to help make our commercial launch vehicle community, our industry, more competitive by offering them this unique capability to support their ability to launch anywhere and anytime. And of course, science. We talk about Hubble, astrophysics. We've had a great dialogue with the astrophysics community. They need that 24/7 connectivity to coordinate multiple science missions and ground telescopes to go look at gamma ray bursts. We understand maintaining those types of capabilities, maybe not what they know today, as we evolve the system in future. The A-Train, right? Aqua, Aura, and Terra, built in the 90s. These things would not have happened without this capability, and we're proud to be that third generation to maintain it and shepherd it gracefully into retirement. Next slide. So how did we get here? How did we make this decision? What was the rationale? Obviously, TDRS started, I like to say, before I was born in the 70s. Proud to have been part of that third generation, but we built the system up over time, initially with 3 satellites. Right now, I think we have 9 satellites in orbit, soon to be 8, providing global coverage. Kevin talked about astronauts not wanting to be in contact with FOD all the time or mission control all the time. We closed what was called the zone of exclusion in the late 90s, adding in birds over the Indian Ocean region. So we had truly seamless connectivity. I was there for that final TDRS launch, TDRS-M, which became TDRS-13 once it was commissioned. I was there for that last day, the final staff meeting for the TDRS project that had been open since roughly 1973. I was there when Boeing, our partners on the second and third generation TDRS, we had our last review, that pre-ship review on TDRS-M. There were people in tears. They were sobbing. They fought to be on the third gen project because they understood the capability and the national importance when they executed the second gen. There's feelings wrapped up in this. And we wanted to acknowledge those feelings through this transition. Ultimately, all good things come to an end. We have legacy missions, SMD missions, ISS. We know those are going to keep flying. We could not continue to add new missions onto the constellation, or we would end up in a situation where we did not have enough supply, enough TDRS in the sky to meet all of those needs. And so after the unanticipated failure of TDRS-8 in late 2022, we made a decision in SCAN. We had to work with our mission directorate stakeholders and say, we have to make a heavy-handed decision. We need to move forward. We cannot make new commitments. Even some of the legacy missions, the launch vehicles, we may need to ask them to transition sooner rather than later. And so worked with our stakeholders, had those tough risk-based conversations. It's drove open transparency across the agency, talking about when SMD missions will retire, right? Because their satellites don't last forever. They run out of fuel. They were open and transparent, sharing that information with us. We worked with the ISS, right? ISS retirement, also kind of evolving at the same time we made this decision. And ultimately, last November, at the APMC, the highest kind of NASA decision-making forum, we made a decision to no longer now allow so-called new missions, right, onto the legacy TDRS system. New missions will have to be serviced by new Earth relay capabilities. I look forward to Joe talking about those in a few minutes. So as we move forward, individual TDRS are going to be retired eventually in late 2030s probably. Then we will quietly turn off the lights for the final time. And this part of the agency's history that a lot of people don't know, I hope there's someone out there who's curious and can write that book or chapter. Next slide. So what does the flyout look like? These are our projections, right? We do the best we can to model how these satellites will decline. Right now, we have 8 in orbit. There's actually 9 soon to be retired, so we did not put it on this chart. But we anticipate we will be down to a so-called, we call it a 3-ball constellation by the end of the 2020s. Of course, this isn't perfect. It could happen as early as 2028, as late as 2033. But we need to manage our demand on the legacy system downwards over the next 5 to 6 years. People ask questions. Are you trying to artificially turn off TDRS? No, that is not true. We only turn them off and supersync them when it's unsafe to continue operating them, or their payloads have degraded where they're not actually providing utility or services. TDRS-10 will retire this summer, and we're carefully watching each of the legacy satellites and trying to update these projections, and we'll share them with our entire community, both inside and outside NASA, from an annual basis from here onward. Big decisions, a lot of risk. I talk about, if you listen to me, touching a third rail. I was asked to touch a third rail, but the entire agency rallied around SCAN, around me as an individual, and I'm really proud and feel privileged on being able to lead NASA through this transition. So that's where we are. I hope people who are involved in this see the opportunities that I see in the tremendous capability that industry has to offer the agency. We'll learn things, risks will be taken, there will be hiccups, right? We all build satellites. We're in this business. It's not going to go perfectly. But we need to charge into the future. And TDRS, a system that was designed in the 70s, was really holding us back. And so now is the time for change. SCAN is committed to change, and I think our user community is starting to see what we're seeing, and I hope they can talk about some of the opportunities they see in this transition. So I think that was it, and we can transition to the next speaker. Thank you, Kevin. Thank you, everyone.
All right, thanks, Greg. A couple things to note. The chart that was just up showed the satellites decline, but you can imagine these satellites are getting used right now. And as they decline, these users need to go somewhere, right? These missions need to go somewhere. And that's, that's a big driver for what we're doing. So instead of building new government-owned satellite relay infrastructure, we decided to leverage our investment in the domestic SATCOM market through CSP and direct new missions to acquire all necessary SATCOM services from commercial service providers. So Joe, this next question is for you. What does the future of space communications look like under the CSP partnership model? And some might be unfamiliar with the model, and so maybe break that down as well.
Sure. Yeah, we'll get right into all of that. Under the CSP model, we are pioneering a new era of space communication and navigation, and features, instead of government-specified systems, partnering with industry. Commercial industry has invested and is continuing to invest billions of dollars into a thriving SATCOM market. And we are partnering with them to extend those services, which currently service terrestrial, maritime, aviation customers, extending those to cover space-based users. NASA's not alone. We are not the only customer in this. There are benefits to enabling this capability for United States space economy, both government and commercial. Under this model, we are creating a portfolio of diverse service offerings. This is reflective of the diversity that's in the service providers today. We have large LEO constellations in MEO, different altitudes, inclinations, and in GEO as well. This portfolio of diverse service offerings is needed to cover all of NASA's use cases, and these different specific orbits are tailored and have key benefits for specific use cases. Next, I'll highlight some of the features that we see in these commercial services that are coming on board that will be revolutionary for our missions. On-demand capabilities. No need for lengthy scheduling cycles. These service providers today can rapidly provision services on demand, machine-to-machine interfaces, enabling our mission operators to communicate with their satellite anytime they need to, wherever they need to. High data rates. We're seeing orders of magnitude increase. Many of our upcoming systems that you're all aware of are featuring optical communication systems that's maturing that technology and providing persistent, high-rate connectivity that will open up new avenues for our missions. Not capacity limited. If you take a look at the total NASA data capacity that we could ever use, it is a small fraction of the capacity that commercial providers can provide. This means that we won't have to have competition over limited resources for access to communication resources. And finally, enabling greater autonomy with these on-demand persistent services. This will be a game changer for NASA missions. We strongly believe that new science opportunities will emerge enabled by these new communication capabilities. Next chart. So what is our strategy? SCAN, we are acquiring commercial services a little bit differently per the mission group. For science missions in Artemis, SCAN's role is the acquirer, and we will be acquiring commercial services for the NASA mission community. TDRS will continue to provide legacy support for those missions, and we will be establishing these new relay services by 2031. CSP project's role, our role here is to validate and transition these services to the NSN, and the NSN will then manage the operations. For commercial LEO destinations and commercial launch vehicles, SCAN has a different role. Here we're a facilitator. And really what we're trying to do here is to facilitate direct business-to-business relationships between those communities and the providers. CSP, we will have an active role in this as well to connect stakeholders to industry partners, share lessons learned, some analysis as well. Finally, for the International Space Station and supporting vehicles, here CSP won't have an active role since we are not pursuing, currently not pursuing backwards compatible services. Next chart. So this is our three-phase approach for the CSP project, ultimately ending with our commercial service acquisition in phase 3. But we'll start at phase 1. Phase 1, this has been completed. We extensively studied, going back to a number of studies, number of years. I was part of those. I know Greg was part of those and many others, studying how to do this transition. What was commercial's capabilities? We did a number of RFIs. We engaged industry, and then we did some broad agency announcement studies as well to get their input. Part of it is technical feasibility, seeing if these services would be able to service our missions, taking a look at extending their capabilities to space-based users, but also the business case. Very important. You need to have a viable market here for SCAN to be able to use these services. During this time, we also established use cases, took a look at how TDRS was currently being used, the performance goals, to ultimately lead to the funded Space Act agreements. The other outcome of the study was that commercial had capabilities and had the infrastructure, but in order to meet our timeline and to extend those services to space-based users, we did need a little bit of an investment, and that's through the phase 2 funded Space Act agreements. In June of 22, we awarded 6 funded Space Act agreements with 6 commercial SATCOM providers. They're listed right here: Amazon, SpaceX, Telesat, and Viasat, which has acquired Inmarsat, and SES. These demonstrations, we're about halfway through the funded Space Act agreements, and we're just now entering the demonstration phase. This is the very exciting part where, as these services are being fielded, now we are seeing the demonstrations and see them used in operations. These demonstrations, this is not a technology demonstration. We are not demonstrating just an optical terminal by itself. These are end-to-end services. That was vital and a huge part of these funded Space Act agreements. So we are exploring the business side, the operational side, the interfaces, the user terminals, the ICDs, the user's guides, everything that we will need to be able to use this as an operational service. I'd like to quickly celebrate some of the accomplishments of our partners. Amazon, if you read Space News, you already know most of these, but Amazon has launched their first round of 27 satellites for their constellation. So very happy to see that first set go up, and there's more along the way. SpaceX, we just completed a demonstration with a FRAM-2. It was a crewed private mission on a crewed Dragon capsule. It was outfitted with a 100 gigabit per second optical terminal, and for 3.5 days did routine optical communications to provide internet to their crew, which was a very successful demonstration, and they'll be sharing more of their detailed analysis with us in the coming months. Telesat, they recently completed a design review for their constellation. Their Lightspeed constellation will feature SDA compliant terminals and will set to deploy here in 2026. Viasat and Inmarsat already has existing operational services in L and Ka band. These GEO satellites are in orbit today, and they will be adding capacity in this year. And then finally, SES has 8 of their 13 satellites for Empower in orbit. The last two just launched recently. And their first demonstration, there's a number of demonstrations that we're doing. The first demonstration spacecraft is with Planet Labs. So we have a company that looks a lot like NASA science missions. So this is a very interesting demonstration spacecraft that is doing Earth observation. And that spacecraft is launched in January, and we'll begin to do demonstrations with Empower with them soon. These are our funded Space Act agreements. I'd also like to acknowledge we have non-reimbursable Space Act agreements with a growing number of companies. Kepler is one of them. I think they're here. And that's another good way that we can facilitate conversations between NASA and industry. So where are we heading? The commercial acquisition, this is the next step in our process. We will be performing additional market research, be finalizing our acquisition strategy, and then completing the service requirements. These service requirements will be with the RFP and define NASA's minimum thresholds for a useful service to NASA. This is an open competition. Although there has been some history with the funded Space Act agreements, this is open. We are looking for mature services from any eligible provider that can provide us they can meet our needs for our spacecraft. After the RFP, there's a validation activity, and then after we pass our operational readiness review, they can enter operations and be entered into the NSN catalog. Next chart. So let's talk about the acquisition timeline. Our goal is to deliver these operational services by 2031 and add them into the NSN portfolio. Going back here, the first step I have here is an RFI. I'm happy to announce that there'll be an RFI released here in a few weeks. And we're looking for a good response from industry to help with a lot of key items. Tell us about your service capabilities. And it's quite comprehensive. It's about the business side. It's about the information you can provide on your user terminals. Tell us about any tracking and radiometric services you might have, fill in some gaps that we're seeing. So the other important thing about this RFI is that under the funded Space Act agreements, we're a little bit limited in what we can share with our mission community. We're hoping through this RFI that we'll be able to share users' guides and information to share that with our user community so they can start thinking about how to use your services. Throughout this timeline here, we are engaging with our mission stakeholders. So the service requirements review is something we'll be working hand in hand with all the mission directorates and with the NSN. There will be opportunities to review those service requirements in a second RFI in Q2 2026. We will provide a draft of these service requirements for industry to provide us feedback. And then finally, the RFP in 27, and then on to the awards. I think that's my last chart. So again, I just want to reiterate on the RFI being an excellent opportunity to provide us with more information and also feedback on our validation strategies. All right, thank you.
All right, hey, thank you so much. All right, the Artemis missions rely on NASA's Near Space Network and Deep Space Network to communicate critical data to and from the Earth. Steve, this next one's for you. Your introductory question: what modifications are being made to incorporate the new partnership model to ensure mission continuity?
Yeah, thanks, Kevin. Like you said, really the capabilities that SCAN brings forward, we could not do our missions without them, right? I kind of see this as transparent, the new model. You know, a lot of things that we're doing, we're acquiring in a more commercial model, which in my opinion, we should do when that ecosystem is out there. And so I see us, you know, what we really need is a seamless transition from TDRS to these new capabilities. Greg kind of touched on it, obviously, Artemis launches with SLS and Orion. We need this capability. Also, you may not think about it, but Orion return, we need it. He also kind of alluded to the landers that are coming on the horizon. You know, Artemis 2 is just going to be a mission with SLS and Orion, but starting with Artemis 3, we'll bring in surface missions with our landers. And we have two different providers for the landers on Artemis 3 and 4 is SpaceX with Starship, and then Blue Moon with our Blue Origin's Blue Moon, which launches on New Glenn. And so those missions are going to expand the need quite a bit, because not only launching those landers, but they each do propellant aggregation in low Earth orbit, which will take some number of missions. So from our standpoint, you know, we've got a great partnership with SCAN, working with you and your team, and it's critical to our missions. And we're just looking forward, as you're moving forward to this new model, we fully support it and look forward to that continued great partnership.
Thank you, Steve. All right, Andrew, your introductory questions next. And after that, I'm going to go through many questions that are from the audience and some that I'm drumming up. Andrew, so we've got a history of RF communications across missions, but optical is something that a lot of partners are bringing to bear. What is the optical communications potential enabled by these emerging CSP partner capabilities?
Thanks, Kevin. I'm going to hijack the mic for just a quick second and double down on some things Greg said. TDRS has been an outstanding asset for science for decades. And I want to send a sincere thank you to everyone here, online, people you know that made that happen. Science appreciates your effort. And as Greg said, it's time to look forward into new things. And I'm excited about that. I think one of the roles of science is to ask what if. And here's another opportunity to say what if, specifically with optical communications. What can we do with optical communications? I don't think we've even begun to scratch the surface of what this capability could enable for science. I think we're going to find new ways of performing science with the communication capability itself. Excuse me. Thank you for your patience as I enjoy DC's pollen season. But with the Deep Space Network RF comm system, we're using that comm system to make science happen. Right? I am eager to see our brilliant scientific community dive into the capabilities that optical comm can do for us, not just in terms of data transfer rates and things like that, which are phenomenal. What science could we even do with that system? One thing that's been abundantly true to me in my 27-year career living in science as a hardware engineer is that scientists want more data all the time, faster than ever before. We have a voracious appetite for data. Things like optical communications can make that happen for us in deep space, near space, Earth relay types of situations. We've got NISAR launching here, hopefully in the next year, that's going to be dumping, 85 terabits of data down. Unprecedented types of data transfer. We want to do even more than that. We're greedy, we're hungry, right? We want to explore the what if of optical communications. That's why the Deep Space Optical Communication test platform resides on the Psyche spacecraft, And we got to send a fun cat video home. But that's a stepping stone to this unique opportunity that the people in this room, the people online are going to enable for the science community. So thank you.
Thanks, Andrew. All right, now to the audience questions. And if we could go back one chart, because telepathically I've received some more questions from the audience out here. And if we go back 1 to 13, there we go. Greg, you're up first. It's a compound question. Okay. You ready? What drove the agency to make the decision to fly out TDRS and stop other users, formulate CSP, and what are the drivers behind this calendar behind you, behind the acquisition timeline?
Okay, yeah, so I'll answer the first part of the question. There are multiple drivers, like everything we do, right? The first, we talked about the technical capability, right? TDRS was 20 years ahead of its time when it was conceived in the 70s. I don't know how that first generation of engineers built this unique, exquisite capability out of what I would call Stone Age technology, right? I grew up in the area of digital signal processing, not analog signal processing. It really held us back, right? Andrew talked about the capabilities we're seeing. Anywhere, anytime, optical, 100 gigabits, that will turn into terabits per second. We got frozen, right? TDRS was ahead of the game. It was an important part of driving SATCOM industry forward, right? All of the partners I've met, they've had individuals who worked on TDRS in the 80s or 90s or the 2000s. It's been part of not just NASA, but our wider space industry. But like, it's holding us back at this point, right? It's tough having those conversations with future science missions. I don't know if I have enough to offer you. Space policy. Space policy drives NASA and all of the federal government to maximize the use of commercial capabilities. And if those requirements aren't there, or there's not a good match, to work with commercial partners to go then develop those capabilities that benefit not only NASA, but the wider space industry to enable U.S. competitive advantage. Third, funding, right? Let's be open and honest, right? A lot of questions about the NASA budget. Maintaining these old systems is expensive. And we at SCAN, we always talk about that tension about how much are we going to contribute or value our future versus just maintaining what we have, which is in most cases representative of the past. So those three things, I think, drove us to that transition. Timelines here, right? We have NASA processes, right? We worked with the agency to formalize a life cycle for this project. Worked with the AA before he departed on that. We also wanted to make sure we had time to let this bake. One of the most valuable parts about this phase 2 opportunity is there a two-way dialogue between commercial and NASA, so then they can evolve their service capabilities to maximize the benefit and value for the agency. Funded Space Act agreements are magical devices. I'm glad we went through the effort of dusting off that playbook and using those, but we need time to have that two-way dialogue, and that's why phase 2 is so important. Otherwise, we're going to go proceed as quickly as possible. We need to make sure we nail the acquisition strategy so it meets our needs, but make sure the incentives built into it maximize the return on value investment for our industry partners. We don't want to end up in another situation or potential situation where the business case falls apart. Yep. TDRS was a public-private partnership, right? First gen. And in the end, NASA had to novate the contract and buy out the system because the demand wasn't there. The business case didn't close. We don't want to repeat those mistakes. Validation is going to take as long as it's needed. If there's people ready who have mature capabilities, who can provide artifacts to the government that this service is ready to go, we're going to be as aggressive as we can to push through that validation period and end up in a position where we have an operational service. Also say, SCAN, right? When do we open up the door for mission commitments to really consider these? We can't do that today. I don't have service providers on contract. But as soon as we have those service providers on contract, then we'll be able to answer some of those questions from our user community and open the door for formal mission commitments. So those are some of those aspects of what drove us here and are driving the next few years of activity. Thanks, Kevin.
Hey, great job. Great job. So I'm sure industry, you have things that incentivize you. We're incentivized by a few things too, right? And we can't control how fast we're going to lose TDRS. And so, to Greg's point, we need to figure out how to bake some speed into this. But I have a next question tied to that for you, Joe. How long of a transition period is planned while we have legacy TDRS available for backup as the new capability comes on board?
Sure. Yes, there will be a transition period as we ramp down TDRS use, ramp into commercial, and there will be a period where those services will be operating concurrently. As if we bring these services on, some might have a quick validation, some might be so it can start sooner. Absolutely, if we can get through the validation processes. But to answer your question, we anticipate there being a period of time where those are concurrent, and probably about the mid-2030s is when we would like to see a transition to commercial.
Okay, thank you. All right, Andrew, given that TDRS services are no longer permitted by AOs, when responding to AOs, will teams be able to choose telecommunication relay services that best fit their needs, or will NASA compete telecom services separately from the AOs, as is done with launch vehicles?
Yeah, that's a great question. This is a really tough time for proposers, right? We're saying you're not allowed to use TDRS anymore, and we can't hand you a menu yet of what communication services are going to be available to you. It's a tough time. But what I envision this becoming is SCAN is going to continue working with our proposers in pre-phase A to evaluate the needs of that mission and figure out how they can pair the needs of that mission with this basket of service providers that they have secured, vetted, validated, and ensured are quality providers for the types of services we need in the future. So I don't think that there's going to be a massive change. I don't foresee protracted LSP type contracts. We're relying on our SCAN partners to do that work for us, to figure out what capabilities we need and partner us with the providers.
All right, thanks, Andrew. Steve, next question is for you. Help us understand how Earth relays enable the Artemis mission and the different things you do in the mission.
Yeah, sure. And I kind of went there a little bit in my opening, but yeah, definitely launch with SLS and Orion. We couldn't do our missions without it. When we were returning Orion with the crew, like I mentioned, we get into Artemis 3, potentially with our landers, or in that whole campaign with the landers and propellant aggregation. We also have for each of those landers an uncrewed demo mission. So even before Artemis 3, we'll need to be, SpaceX with Starship will need to be doing an uncrewed demo. And so every time, not just the Artemis mission itself, but any time we fly, it's critical and enabling to our missions, Earth Relay is.
Thanks, Steve. All right, next one's for Joe. Given NASA's recent selection of Intuitive Machines as Lunar Communication Data Services partner, what opportunities for commercial communications are in planning?
The next opportunities for commercial communication, CSP is of course the one that's here on the timeline, up and coming for near Earth proximity users. There is also some activity through the Mars Exploration Program looking at commercial next generation relays for Mars. And I know there's some studies that were completed late last year, and that program will continue to look at commercial approaches for Mars.
Yeah, if I can follow up, right? Yeah, if you're familiar with SCAN, right, we divide the whole universe into kind of 3 regions, right? Our LEO region, we're talking about CSP, right? The TDRS cloud and the CSP on-ramp is going to really dominate the evolution of that architecture. Lunar, right? Intuitive Machines, another partner, right? Building out lunar relays to enable Artemis and science missions, maybe making a national asset of that someday. We have those plans in place, those contracts, right? We've moved that ball forward. Maybe we need to do more there in the 2030s. But the next place SCAN is going is on the future of DSN Mars Relay. We're going to consider those things together. Right now they're coupled. We have to consider that question at the same time. They're not separate. And we will see, right? Are there, as I like to call them, big C commercial opportunities there where there's a market, where an owner-operator has a business case, or maybe little C commercial where there's tremendous industry capability, maybe driven by what's done in LEO today, where we could take advantage of that in establishing the next generation of Mars Relay. So yeah, we're going there. Pay attention. We have our outreach arm, CIS. Those are the places SCAN is going, and we'll likely look to accelerate over the next 1 to 2 years.
Hey, thanks, Greg. All right, Greg, back to you. When we issued the memo in November saying no more new TDRS users, wow, I learned all the TDRS users I didn't know about. I got letters, phone calls, the A-Suite got, phone calls, Congress got phone calls, because this is their business. And they're like, whoa, wait a minute. This is an interrupter to my business, my ability to compete even. And so I want to pick on one segment of that, and that's launch vehicles. Many of them use TDRS to meet NASA or Space Force contract requirements. As TDRS has flown out, how are NASA and Space Force managing their requirements and contracts that TDRS supports?
Yeah. The last 6 months after we sent that letter, a lot of good conversations. I think I was called a breakup artist during the time. We want to be good partners, right? And part of that partnership is not cutting people off. It's making sure they have runway to change and transition. So working with the commercial launch vehicle community and even some of our international launch vehicles we support, we said this isn't a today decision, but the data tells us we need to get you off the system before we end up in what we call a 5-ball, 5 TDRS constellation. Supporting launch vehicles, yeah, it's not every day, all year, but those launch supports, that's an intense 24-hour activity that puts a lot of the demand on the system. We need to keep getting Hubble data down. We need to keep the ISS astronaut happy. And so we set kind of clear expectations. You need to start moving. We gave them those timelines, and we listened to them. We talked about that facilitator role. I've seen just that strength in us all having open, transparent, sometimes brutally transparent conversations. Some of those RFI questions, I think, are posed to the launch vehicle community. Be open with us, and we'll play our facilitator role where we can come together, maybe later in the year, to talk about those things. There's a need here. LSP is doing the right things contractually. They have their relationship with Space Force on these types of needs and requirements. We understand that, and we want to advance everyone's endeavors moving forward, and we'll do that by just forcing the conversation. But again, I think NASA's not the right solution anymore, especially as demands of launch, responsive launch, anywhere launch start to grow. Maybe there's a better solution than what we have with TDRS today. So let's go find it together.
Okay, thank you. Steve, with respect to cross-functional collaboration, how does exploration and science work together to ensure SCAN meets your joint set of needs?
Yeah, I'd say the big thing is communication, Kevin. You know, on Artemis 1, that was one of our lessons learned, is I think we had working level and at the integration level, but we really needed more communication at the leadership level. We needed more communication, you know, of priorities. And so we've really, I think, intentionally, collectively ramped up that communication. You know, Andrew and our mission managers and Greg meet every Friday now. We know we have a tag with you at our leadership level. We've tried to do face-to-faces to really understand and a couple of things in my mind that have come out of that really bared fruit is like the first priorities. You know, we learned on Artemis 1, we put everything, we were number one priority. Well, we had 9 secondary payloads on that flight that probably should not have been classified as priority over flagship science missions. So we're reclassifying and making sure we're clear about when our real priorities are at critical mission events and critical parts of the mission, so that we don't create that conflict with science. And the other thing we're doing is another example I'll give in a little lessons learned. I think with better communication, we can talk about what our real schedule is, and SCAN can react. One of the things we found was, you know, we were putting blackouts for when we're going to launch, and then our launch date would move, and that time was not, you know, taken advantage of. So more integrated communication and more responsiveness, so that the assets that SCAN has are not, you know, being idled in when we think when you think we're going to need it. So I think, like I said, Artemis 1 was a big success, but we learned, in my mind, that more communication is needed for the complex job you have, and that you're orchestrating with all your users, and then particularly for our missions come in. Even more than a commercial launch, an Artemis mission comes in highly intense, and crew safety is going to be critical now. We would start with Artemis 2, of making sure we're communicating of what our needs are and what the real priorities are.
So we asked that question. I hope it illuminated for you that being a commercial provider and supporting Steve's missions, boy, that's a blip in your system. Because you may drop other customers, you may have to. He may have rescheduled by a week, and now you're telling everybody last minute you can't do something. It's going to impact your SLAs. This is something big to bite off. And so, if I was you from a risk perspective, I would spend a lot of time understanding how human spaceflight leverages these capabilities you might want to provide, because it could be something that you either plan for and you do well at, and make profit on, or it could be something amazing you do that's a loss leader, because you didn't think about it right and negotiate it right. So that's a very important set of statements. Andrew?
I'd like to jump on top of that, Steve. You know, from the science perspective, absolutely, we need to be communicating better. The three parts of this organization collaborating on this great effort. And I'll take this opportunity to do a little nitpick on the slide. I think we've got a resounding theme here that we've seen in the agency of science enabling exploration and exploration enabling science. And that speaks really deeply to me that we are hand-in-hand partners with human space flight. They aren't over there and we're over here. We need to be collaborating and in lockstep and coordinating our activities, and it all comes together at SCAN from the communication front. I've been designated as SMD's Senior SCAN Liaison, the SCAN Whisperer, et cetera. Science Mission Directorate has realized that this needs to be happening. And in fact, they've tasked two of us from the front office to purposely and proactively engage with SCAN. We meet multiple times a week to make sure that what we're doing, what we're envisioning for the future and what's going on are all done in a really well-coordinated way. And I'm excited to be a partner in that.
Andrew, thank you for calling out the slide mistake. When I first came to NASA, I met Nikki Fox. There were two things that happened in that first interaction. I called her a customer, and she stared at me. And I said, well, you're a customer. And then we changed that on the spot to science and exploration enabled. So that is a mistake. Since then, all of our slides have said science and exploration enabled. So apologies to Nikki. Andrew, this is right back to you, though. We talked about some of the interesting drivers of Artemis on this future relay. What are the science drivers?
Wow. So, you know, when we started looking at TDRS flyout, we really said, do we need Earth relay? And it was a resounding heck yeah, right? And I'll tell you that was validated by the panic that we heard through the science community when we said, hey, by the way, we're turning off your access to TDRS, right? That kind of closed the loop for us. That yeah, we're onto this. You know, most notably, I think space relay or Earth relay, sorry, is really critically necessary in astrophysics. The type of observations that we're doing necessitate constant and continuous ability to access our space assets, to point them strategically as maybe a once-in-a-lifetime astrophysics event is occurring. That's an easy one right off of the top. I think you could see that evolve into new mission paradigms that can be enabled by having constant connectivity to our spacecraft. Right now, we've got these little buckets of time slices that we spend a lot of time juggling coordination and scheduling, and we bin up all of our science data and we dump it down at these little drips and drabs that we have the opportunity. I can imagine a future state where this new network of communicators allows us so much more flexibility in how and when we can collect our science and command our vehicles. I think that the opportunities really are exciting and compelling for science in the future.
Thanks, Andrew. Hey, Steve, NASA is going to demonstrate optical communications with Orion during Artemis 2 using O2O. Will optical communication be part of the Moon to Mars architecture?
Yeah, I'm not sure that, you know, that's in front of us a little bit, but I would think so. Yeah, on Artemis 2, we've partnered with Lincoln Labs and doing that demo, really exciting. What I would tell you is, I mean, particularly with surface missions, our appetite for data is just almost unquenchable. You know, and you think about video and the importance of video for you know, public affairs and STEM kind of reasons. I mean, the public is used to having high quality video all of the time, and when we're doing these missions and astronauts are on the surface of the moon, you know, I think that is going to be a huge need. Also, our science community, represented by Andrew, I mean, there's a real science need to have data and video real time as our astronauts are exploring. So I see it as it's a great technology to give us so much more data. I can't imagine it's not going to be right now. It's more of a demo phase, but I can't imagine that we're eventually not going to want that, and it'll have its place. I think we're still going to want S-band for those critical events, you know, with the crew and landing and those kind of things. But I see it as having a real opportunity in the architecture.
Thanks, Steve. So, Joe, CSP question. Are any radiometric or tracking data services being demonstrated by any CSP partners? Are tracking observations being considered in the service requirements development process?
No, so not currently. We don't have any tracking or radiometric services part of our demonstrations. We did ask for industry in 2021, part of the announcement for proposals leading to the Funded Space Act agreement, if there was any interest or capabilities in industry for those services. We did not get a response at that time. But tracking and radiometrics is very important to NASA. Some of our spacecraft are very elaborate and require precision pointing accuracy that is beyond what you can do with just GPS alone. So again, to promote the RFI, we will be asking industry again for if they have any tracking and radiometric services they could offer NASA as part of services, and we encourage you to look at other Alt-P&T concepts, anything from optical radiometric, optical metrics, any other innovative solutions that might help our science with that key problem. So depending on the RFI response, that might influence if it shows up into our service requirements or not.
All right. Hey, thank you. All right, Andrew, you're on the spot next. So we developed these commercial tenets of working with commercial space partners. The first one is to get behind their path to profitability, which means I need to do everything I can to drive customers to them. What is SMD doing to communicate to their advisory board and the PI community stakeholders these changes and opportunities and help drive them toward these commercial partners?
So I'll start off by saying I think we can do more and I think we can do a better job. But that doesn't discredit the efforts we've already taken under. We've invited SCAN to come to federal advisory committees to participate we participate in their CSUGs, their commercial services user groups, and those are ways to get out to the community. In fact, this forum itself is another one of those opportunities that we're hoping to capitalize on. We absolutely want to hear from everyone. What are we missing? What are we leaving on the floor? What opportunities are we not capitalizing on? Because the viability of this is vital to our sustainability of being able to continue the science that we're doing. This business model is part of SMD's business model, and we have to lean in and embrace it and make sure that we're feeding it as good custodians of the service.
All right, thanks, Andrew. Steve, Moon to Mars has their own set of commercial service procurements and partnerships, and I'm sure you guys have learned a lot. What kind of lessons would you share with us for this acquisition?
Well, I think first thing that for me personally comes to mind is, you know, if you're going to do this kind of approach, you really want industry to be interested in an ecosystem out there, which I think you clearly have. The next thing I would say, lessons learned from us is, you know, you really need to early get your requirements settled and not, you know, and make sure you're confident in what you're buying and what kind of, you know, requirements from particularly performance. I would say be flexible, look at what you really need and what's out there. You know, in the past, like with the lander, we actually set a threshold and goal performance requirements, which I think help because you don't want to put out something that's going to be you know, overly expensive. The other thing in our world, and I'm not as familiar with your world, is, you know, the how-to requirements I think are really important. Design and construction standards and other things that you put in as part of the contract. You know, what we did that I think that's worked really well is adjudicate those in an early phase. I think you want to settle not just performance requirements, but your how-to, design and construction standards, other standards you're going to put on the provider, and give them an opportunity to push back on those, and really make sure you buy off on those up front. You know, and the bad lesson learned I've had in my history is letting that go on too long. And so you really want to get that buy-off from your user community and your technical authorities. And the other thing I would say is thinking about your kind of management model. It's not an oversight, it's more of an insight, in making sure you're on the same page with your partners of how you're going to do that. And the last thing I would say is, and I'll stop here, I could go on this subject for a while, is really look at how you're going to do what I call collaboration or offer up capabilities the agency has to commercial industry. And how you do that, and that you make sure you make that, and that might be hardware, it might be expertise, that you have a structure where you can make available and help industry or capabilities at the center and let them work for your provider, not directly for you, but make sure that you offer those up and you have a kind of a structure where you can manage that, so industry can leverage the investments that we've made in technology or expertise that might be out there. So those are some of my lessons learned that I think have worked well and not worked well in the past.
Hey, Steve, that's great. I appreciate that. That kind of feeds in now what I'm going to ask you, Andrew. TDRS has a DAS capability. I want you to tell us in a minute what that is. You know, how can that be replicated with commercial providers? Is there a potential to test any commercial solutions with existing platforms? Tell us about those platforms. Why do we even do DAS? Will that continue? How important is that to SMD? Help people understand in case they have an opportunity to cling on to this, right?
Yeah, I touched on it a little bit earlier. You know, DAS is demand access service. It's a capability that TDRS provides to us to say, we need to talk and we need to talk now. Not the call you want to get from your partner, but it's an exciting call to get in science because that means something's happening, right? And we want to respond to it. And ensuring that that capability exists in this future paradigm is of critical importance to our astrophysics community. They have been one of the staunchest advocators and interested parties as we're talking to SCAN about what's coming next. And every single time we talk to them, it's DAS. How are we going to do DAS? I think that this new commercial service paradigm absolutely is compatible with the tenets of DAS, whether you call it DAS or not. I think that having a 24/7 connected network of providers with redundancy across multiple providers is going to provide, I'll say that again, is going to offer that kind of capability to our community. And in fact, I think there's an opportunity for that to grow beyond just astrophysics. I think as other science communities realize that this capability exists, they're going to want to leverage it. They're going to want to talk to their satellites more often. They're going to want to see what they can do with their mission paradigms and their mission designs, their ConOps, to say, how can we use this to do our science differently, do our science better? How can we capture those unique opportunities that we're currently missing because we're not engaging in this arena?
Hey, thanks, Andrew. Greg.
I missed one point of your question, though. Sorry, let me go back to that.
Oh, yeah, right.
Opportunities to test this stuff,
yes.
Right? So there could be an opportunity to I'm definitely interested in exploring the possible opportunity. I'll put all the weasel words in there so I don't get in trouble, right? One of our assets, Swift in astrophysics, is a user of DAS in its mission paradigm. And I would love to see an early test run, a trial run, a risk mitigation test, to put it in engineering terms, to try it out. Say, hey, does this work? Does this meet our needs? And what about it doesn't meet our needs? You know, we're a learning organization, and in order to learn, we need to try stuff. And I think I really want to see us leaning into trying stuff as we move forward together with the commercial community.
Thanks, Andrew. Greg, we received a few questions on S-band services. Is there a plan to replace current S-band services with commercial ones?
So no, not yet, maybe. That's the concise way of answering it, right? Our approach with CSP was to move as maximally towards the commercial capabilities as we could. We want to be one of many. We won't want to drive unique government requirements into commercial SATCOM ecosystem where we're the only user of some bespoke service. But this is a conversation. We talked about the CSP life cycle, making sure we had time to consider some of these questions, make adjustments as we moved along. And in the whole TDRS flyout process, where we're looking at missions, not just missions today, but concepts, you know, physics is physics. And that region of the spectrum around the mobile satellite service bands is pretty unique. It allows you to do some unique things, the DAS thing, right? I have a tumbling spacecraft, I need to try to recover it. And so there's some commercial capabilities that are very similar to TDRS. They're in different bands, L-band. But could we partner with commercial, working with the FCC and NTIA, maybe making adjustments to the table of allocations and allowing authorizations for a commercial service with a business case to be formulated around an S-band relay service. We're going to ask some of those questions in the RFI. If we have driving requirements, we have a match of technical capability and a business case, plus the spectrum regulatory regime questions are answered. I think that could all add up to yes. We talked about communication about 7 different times, not services, but also us all talking together. We're going to ask those questions. We're going to have those conversations over the upcoming year. That may turn into effectively new requirement for SCAN that we'd have to execute on in partnership with some of these commercial players in the room today. So yeah, evolving situation. We're gathering that information to make an agency judgment on how to move forward in the best way.
All right, thanks, Greg. Steve, the next one's for you. The need for Earth relay support of HLS from both SpaceX and Blue Origin LEO refueling operations was not known when SCAN defined its transition to commercial relay capabilities. How is this new need being accomplished by the agency? Is it really an HLS contractor responsibility?
So I think the last part, yeah, at the end of the day it is, but of course our approach is try to help our providers all we can. I think, you know, at the end of the day, we want the mission to be successful, and so making, you know, part of the other thing when you were asking about, you know, this commercial model, the one other piece I would add is part of our government role is to help integrate. You know, we are a big organization. There's a lot, you know, in Moon to Mars, there's a lot of programs working with SCAN, and so part of our job is when our partner, provider, or contractor needs help, even under a commercial model, you know, in my mind, it's one of our big jobs is to help integrate and go help fix that problem. And so I think that's what we've done in this case is while it started out, maybe we don't need that, you know, as we've gotten closer, we realize we do. And so I just appreciate the partnership with your organization and working through that and putting the mission need first and understanding that, you know, at the end of the day, we can have, you know, sort of goals and ideas about maybe we don't have S-band or maybe where it's all commercial, but at the end of the day, we need to jump in and solve the problem, you know, and make the mission go at the end.
Thanks, Steve. All right, Andrew, you're up next. Is there a killer app for commercial space services?
Killer app.
Let me rephrase that.
Yeah.
The science missions are hard enough. You know, they have this whole, you know, they're all so different, right? They all have different needs, but the one need they have is to get the data down. But, you know, what is the easy button industry can do that makes science start banging on their door?
As I touched on earlier, you know, more data, faster, feed the science machine. It's a voracious community. If you can find ways of doing that for science, they will celebrate you. They will come to you begging for more. I'll say it, we will come to you begging for more. You know, I've touched on it a few times. This opportunity to explore what constant comms with our birds could mean for us is really exciting to me. So if you say a killer application of what this new capability might unfold for science, you know, I don't want to suffer for a lack of imagination. but this could really change the game in how we do science. It could set the stage for the next decade or two of fundamental ways in which we capture science, communicate science, bring science back to Earth, and share it with the people. I think there's also a really compelling opportunity to leverage a network of connected space assets to actually do science. You know, what if we could put a sensing instrument on some of your birds? What if we could do global rainfall measurement from hundreds of assets or more and constantly be communicating that down? What if we could explore space weather events on a global scale simultaneously instead of a single asset flying around? You know, these are the kinds of things that excite me about what I see coming in the future from a science perspective.
All right. Hey, thanks, Andrew. All right, Joe, next is for you. You know, you've been through the CSP journey. You've probably heard a lot of complaints and lessons learned from CSP partners. And you've got your own pains and lessons learned. What do you want to share that will help this next phase go smoother?
We touched on it earlier about communication, being a communication org. These relationships are built on trust. Like any relationship, they take work to be effective. So what we put in, we get back. If we engage with our partners, provide them feedback, which is what they really need, is feedback, then the insights that we provide will result in a better service for NASA. It forces us to do our homework and to be engaged with industry, also to be direct and tell them what we need, but not how to do it. And other key lessons learned that we've been having is to, anytime we've facilitated conversations between the mission directorates and the providers, good things have happened. I can think of a number of examples when we get the two together, and then if there are a slight gap or something different than what they're expecting, we can work through those things. And the companies are anxious to understand those problems and to start working them. I can think of a number of examples where, concerns about a tumbling spacecraft, something in an emergency mode. What about this contingency mode? Hey, your system relies on GPS. What happens if you don't have it? That gets them thinking, and then they can start innovating. And they're anxious to do it, and they're willing to do it. They just want to understand how to make this work. So that's been lessons learned for us, and some examples. So.
Great, thank you. And Greg, congratulations, you get one out of left field. Are you ready?
Oh, the best question.
Yeah, it's a compound question again.
Oh, man.
First, what keeps you up at night? But the second one is, what are your known unknowns on this?
What keeps me up at night? A lot of things. I want our customers, our users, to trust SCAN, our vision, and know, even though we're going to have tough conversation, SCAN's place is to be a means to those greater ends, right? We're not going to build services that no one uses, right? We need that feedback. So I hope I'm in a position today, and that even grows further, where if I show up, a representative SCAN shows up in a room, whether it's a PI room, a FACA room, a Mission Science Division room, or the A Suite, right? They know we're fighting for our users. We all have constraints, externalities, policy, funding, all those things, but we're doing the best we can. We're here to enable exploration in science, or science and exploration. So yeah, that's what keeps me up at night. Known unknowns. Well, I think we have a known unknown, and that's what the exact services we're going to have in hand to offer our providers, right? We cannot do that today. We can tell you about our partners, whether you're a funded Space Act Agreement partner or some of the non-reimbursable ones. We can tell you about our market research. But until we have those services on contract to go validate, I'm in a very uncomfortable position. I can't start a mission commitment machine. I cannot go to a pre-formulation mission and say, here's your 7 options. What works the best for you? So that's something we actually didn't anticipate in this process. We thought the TDRS decline would give us a little bit more runway where we wouldn't have to stop new mission commitments before we had those contracts in hand. And so that's the biggest known unknown. It's been very obvious from our mission community. Give me those ICDs, those user guides. We're encouraging our partners to share those openly, even though there's a tension with your competition, right? that's the biggest known unknown. We've identified it, and we're trying to work through it in every way possible.
I'm going to throw one more on there. How do you feel like what we're doing and talking about today is supported and will be supported to development and delivery? I'm going to say by those that give you money, by those that give you requirements, by those that enable this to happen.
Supported, but well, again, there's that trust aspect. We've built a lot of trust. We have mission stakeholders. We have leadership stakeholders. We have congressional stakeholders. We have the Office of Management and Budget. We have policy stakeholders. I would say that the tenor of how we're retiring TDRS, that the agency fought it, right, for honestly probably 5 years, and we had lost that schedule opportunity. I've seen support everywhere, but also an acknowledgement that there's risks in these transitions, and it requires resources, whether it's schedule or budget, to go buy down those risks. So there's tremendous support. I see the energy in the industry community. Every one-on-one, I have a partner or a non-partner. They're jazzed about this. They see NASA leading not just for NASA, but for the rest of the commercial future space owner-operators, the Space Force, elements of the DoD, let alone international space agencies. NASA doesn't have the dollars, right, to move the entire industry ourselves. What we have are two unique things: our leadership ability, and then also we talk to everyone. NASA is in the nexus, in the middle of the entire US space industry, international, the industrial base, the interagency. And so people are looking for our leadership, and we're using that to help move this entire endeavor forward. Yeah, so the support is good. That can come in many different ways and flavors, and I appreciate everyone seeking out and supporting our leadership in this endeavor.
All right, Steve, this one's out of the left field for you as well. Are you ready? All right. What's keeping you up at night about this? And with respect to this, what's the last thing you want to go in and tell Amit if it falls apart?
In this realm, there's a lot that keeps me up at night. But, you know, I think in this realm, you know, we've got existing systems that that are using TDRS that we've designed to. And so, you know, being able to make this transition on our side with the actual hardware, you know, it'd probably be a bigger, hate to go tell Amit, but, you know, I really am encouraged with that, you know, we continue to have challenges in you guys supporting our mission and working together, you know, but we still keep meeting those. And so, you know, I know that he knows that your partnership is there, and that's the biggest thing that matters to him. So I don't think any problem I'm going to bring him is going to freak him out, because he knows you and your team are there to support the mission. So
thanks, Steve. Thanks for letting me throw you that one. All right, Joe, how can everyone learn more about CSP, the FSAA partners? Is there a forum or event they can participate in? Who do they call?
Absolutely. We run a CSP users group meeting at least once a year. That is an excellent way to get engaged. It brings the mission directorates with CSP and the partners together. That is an excellent way. You can certainly reach out to myself and project manager Tom Casfura for more information. We'd be happy to facilitate any conversations between you and the partners. We have a mission analysis group, a mission support group that is there to help you for the missions, to help you understand how these services work, the ones that we're working on right now, and to also engage with us on your requirements. We are reaching out, so if we're not talking to you, come talk to me and make sure that we get engaged.
All right, hey, thank you. And if we could go to the next chart. I think there's some POCs up there that were the background for your answer. Next chart. There we go. So these are some folks you guys can reach out to. So this concludes our questions. Any follow-up questions can email to the appropriate point of contact on the screen behind me. A recording of this town hall will be available on SCAN's website. Before I wrap up, I want to take a moment to thank our panel and everyone here for attending today's town hall. Your time, attention, and thoughtful engagement made this a very vibrant and insightful conversation. As the agency moves forward and transitions to utilizing commercial relay services, we invite you to continue the discussion. Come see us, engage, submit white papers, questions, respond to RFIs. We are available. Let's work together, forge this new era of space communications, following TDRS that leads to advancements in space exploration and research for many, many decades to come. Thank you for coming.